good morning. Continuing with chapter number 3, current electricity. We'll be starting with free electrons. Every atom of a metallic conductor has one or more outermost electrons which are weakly bound to the nucleus. These are called free electrons. The negative charge of the electrons also gets transferred as a result of this motion. The free electrons in the conductor are carriers of the negative energy. Now we'll be seeing how they are carriers of the free electric current. In an electric circuit, the negatively charged particles flow through the wire. Metal wires that are directly connected to each other with metal connections are all at the same electric potential, and this is how the blue the blue charges are negatively charged particles, only which moves when potential difference across to the wire is applied. What electric current is? If the charge Q is flowing through a cross section of the conductor in time t, then the current I is given by Q by T, which is the charge of one electron is 1.6 into 10 raised to minus coulomb, which C stands for coulomb. Ampere 1 ampere current is said to flow in a conductor if 1 coulomb charge flow through it every second. Now moving with what Ohm's law is and how it is related to resistance. German scientist George Simon Ohm, he explained the relationship between the current flowing through a wire, that is I, and the potential difference applied across it, that is V. So the relation is V is equals to I, that is the potential difference is equals to current into the resistance applied resistance of the conductor. This is known as the Ohm's law. This is how the ohm is designated. 1 volt upon 1 ampere is equals to 1 ohm. What resistance and resistivity of a conductor is? They are constantly in random motion. When a potential difference is applied between the two ends of the conductor, these electrons start moving from the end at lower potential to the higher potential. As we had seen how the blue charged negatively charged particles that was in blue color, how they move from the lower potential to the end at the higher potential. What resistivity is? At a given temperature, the resistance R of a conductor depends on its length L, area of the cross section A, and the material it is made of. So R is equals to, that is resistance is equals to rho into L upon A, that is the length of the conductor divided by the cross section area. Now we'll be seeing what electric circuit is. There are many appliances in our home which is monitored with the electric circuit. A continuous path of an electric current through conducting wires connected to the two ends of a cell and other resistances is called an electric circuit. So in an electric circuit, a resistance is present, the voltmeter is present, ammeter is present. Voltmeter, it gives us that how much potential difference is applied to the wire, whereas ammeter shows how much current is flowing through the wire, the conducting wire, and the electric cell. That is the on and off button which we have in our circuit at our home. And this is resistance. And in the next video, we'll be continuing with how the electric circuit is made and how the wires are connected and what is the use of the resistance and all things.